last night's homework. You had practice 8-6, this worksheet. You need to have it on your desk in front of you. You did have all 13 on this page. We are working with law of sines and law of cosines yesterday. This is something new that we introduced. I want to say that this video and all the videos that I've done for you, they are on YouTube. This one I'm going to put on YouTube, so it is there. By the time you watch this, it's going to be on YouTube. So tonight, as you're reviewing this, if you need to go back and watch this again, if you didn't quite catch it, you didn't catch it yesterday as well as you wanted to, always use that YouTube. When I show these to you in class, they're on YouTube. So they're available to you, so you can go on there and watch them later. Okay, let's kind of get back into thinking about this thing called law of sines and cosines from yesterday. We're going to look at number 3 here. This is just one that I'm choosing on the top half that we need to consider. If you're looking at a problem like this and you have a triangle, we've used a lot of trig in this section to work out and find any side that we don't know of a triangle. We can always find it given enough information. Okay? Now, you take a look at this, and first thing you want to ask yourself is this a right triangle? Because you guys know, we've done a lot of work with right triangles. Most of your test tomorrow is going to be dealing with right triangles. You'll have an angle in here you're standing at. You're working, I don't know, with opposite and hypotenuse. I'm just making this up just to kind of remind you, what have we been working with a lot? Right triangles. Okay, but you take a look at this black one on this number 3 on your homework from last night. Not a right triangle, so we're not going to mess with opposite side, hypotenuse, adjacent. We don't need to do that with these. We are going to do something totally different. Okay, and you take a look at what you are given. You're not given your 90, but you are given 2 different angle measures inside this triangle. Okay, now if you'll remember from yesterday, do we work with the law of sines? Or do we work with the law of cosines if we want to solve this if we're given 2 angle measures? If you guys remember, most of y'all are getting the hang of this. If you're given 2 angles, this is the place where you use the law of sines. If you were only given 1 angle, that's the place where you use the law of cosines. Okay. By the way, I put this law of sines and cosines review. That's the name of the video. If you want to search it on YouTube, you can write that down. This is what you will search, and it should pop it up one of the first videos that you pop up on YouTube. Right there it is. Okay. Now, take a look. We're given 2 angles. 73 degrees is there, 83 degrees is there. Whenever that happens, we are going to use this little trick called the law of sines. Okay, and here's what it is. If you were absent yesterday, this is an excellent review on what you need to know. You see 2 angle measures. We are going to use this setup called the law of sines. We're not using cosine at all. We're not using tangent at all. This is called the law of sines because we're only using our sine trig. Okay. Now, what always goes right beside your trig every time you have some kind of trig? It always has to have an angle measure right beside it. It can't come alone. It needs this angle measure to be right in those parentheses. You're going to look on your picture here, and you're going to see if you can find an angle measure that has something written on its opposite side. Okay? Take a look. Which angle measure has something on the opposite side, the side across from it? Take a look here at angle G, which is 83. Across from this 83 has an X right there. That's going to be one of the combinations we're going to use. Okay. So we're going to set this ratio up here. Sine of what always goes right beside your trig. Now you guys should just be able to say this in your sleep. So if you don't know the answer to that question, then you need to wake up, because I've said it over and over and over. We need to get this in our brains. What always goes right beside your trig is an angle measure. Okay, that 83 is going to go right in there beside sine. And then on the bottom, put the opposite side. What's the side across from that 83? X. Over here, we're going to do the same thing, We're going to put an angle in here beside of our sign, and we're going to put the opposite side measure right in there on the bottom. Okay, what is the only, well, take a look here. They give me 73, that's nice of them, but what's the problem with that? Now, I wrote that on there, there's that, we can ignore that. Is there anything on this opposite side that they're telling me about GF up there? No. So I cannot use 73 here. I've got to use this other side that they give me in order to be able to complete this proportion. Okay, so we got to do a little bit of work right here. I need this angle that's opposite 58 because I can only use these together with their opposites. Okay, how are you going to find this angle? Well, use your knowledge of what you know about triangles. You have 73, you have 83. We can always find a third angle by adding those together and subtracting from 180. So let's do it. Okay, if you got a calculator nearby, you don't have to do it by hand. Punch it in your calculator. I got 24. Now, I have not worked this out on my sheet, so if I happen to make a mistake, tell me about it tomorrow when I come in. If you disagree with something I have here, we'll talk about it tomorrow. I don't have the answer key in front, so I'm just working this just for the first time here. So let's set this up. 24 is what I found for that angle. It's going to go right beside your trig sign, and then what is the sign that's opposite that? That's your 5.8. And that's always going to go on the bottom of your ratio. Okay. Now take a look at this setup. You have a cross product here. Your x is located here, so we can take the other cross product and solve this proportion. Sine of 83 times 5.8, multiply there. Whatever that gives you on your calculator, just punch this in. After you hit enter, we're just going to divide by that other thing that's across from x. Okay, so this is just a proportion setup. Okay, make sure your calculator's in the correct mode. It's got to be in degree. Okay, please don't throw away these signs. And now, wouldn't you know, I told you guys to make sure yours is in degree, and I just assumed this one was, and I just did it, and it wasn't in degree. I got a negative answer for mine, and I know that I should never get a negative for any kind of length. Okay, so that's what clued me to say, wait a minute, I know that I can't have a negative number, so let's go check our mode. Is it in degree? And mine wasn't. So it's a good lesson learned. If you get an answer that doesn't make sense, you might be in the wrong mode. Okay. Now, let me do it again. And let's see what it gives me. Okay, when you punch this in, cross multiply, divide, your answer should be 14.1536 if I round off to the 4th decimal place. Now, does this answer make sense in real life? Take a look at it. What do we know about angles and their opposite sides? If you have an angle and it's really small, the opposite side is going to be really small. But when you have that angle that gets really wide, you're going to have an opposite side that's really long. So it kind of goes together. It corresponds. It does the same thing. Smaller, shorter. Your angle gets bigger, your opposite side gets longer. So look at it. We were given 5.8 is opposite 24. That's a small angle. Okay, 83 is a lot bigger than this 24. So what should be true about this opposite side? It should be bigger because this angle is wider. So this side should be bigger than this side because this angle is smaller here. Okay, does that happen? 14.1536. Is that bigger than 5.8? Yes, it is. Okay, so this is a legitimate answer, so you can kind of check yourself as you go along. What if you get a number that's like 1,253? You know you did something wrong, so pause and go back. What if you get get a negative answer like I did. You can never have negative distances. Okay. All right, let's do one other problem on this worksheet for this video. And we need to do one that's down at the bottom half, the second half of this. Numbers 7 through 12 are using law of cosines. Okay? And we'll talk about why in just a minute. Number 10 and 12. If you tried those and you gave it a shot and you got the setup on those, everybody can get the setup. That's wonderful. I will not give you one like that on your test tomorrow. So for the sake of time, today I'm not going to go over either one of those with you. If you're curious about the setup, feel free to ask a neighbor, see if you'll have the same thing on your worksheets there. Setup should be the same. The way you solve it's going to be a little bit harder. We may hit it tomorrow before your test. We can talk about it. But on this video, we're not going to do one of those. How about we take a look at number 11 together? Now, on number 11, you take a look at this. Is it a right triangle? And no, it's not. You've got 89 degrees in there. So we need to either use law of sines or law of cosines. You take a look here, and you've only got one angle measure. We don't know this one at U. We don't know this one at T. So in this situation, you cannot use the law of sines because you need two angle measures for that one. Okay? If you don't have two angles, you've got to go with the law of cosines for just one angle. Okay? All right, here we go. Let's remember from yesterday, what is your setup for law of cosines? I'm going to do it down at the bottom because this does take a lot of room. Okay? So the thing that you always lead with your law of cosines is this side that you don't know, and you're going to have an x squared out here. Okay? You do need to remember this process for your test tomorrow. You've got x squared starting off. You've got a lot of stuff on the right side. If you will listen and kind of try to think about this and try to remember as we go, I'll give you a couple hints that will help you remember what is the law of cosines. Okay? First things first, we are going to set this up kind of like Pythagorean theorem. Now, it's not Pythagorean theorem for real because we don't have a 90-degree triangle. Okay, but this is going to be your first step in the setup. You're going to take your other two sides, 14 and 15, and you're going to square them and add them together. Okay, this is the first part of your law of cosine setup. Look at your page, make sure you've got that first. On this setup here, this looks like Pythagorean theorem. It does. Okay, we've got something squared equals 14 squared plus 15 squared. That's going to be your first part. And then what's the next thing that's always in your setup? This is where you get your minus 2. So you just need to remember minus 2, it's always there. After your square, you put minus 2. And you are going to use this 14 and 15. You're going to use those side links again. I didn't do this yesterday, but I'm going to use parentheses for this. Sometimes you get into some decimals here, and it can kind of just all run together. So I'm going to do this. I'm going to use parentheses. We're going to multiply. We got minus 2 times 14 times 15. The last part of this is always cosine. This is called the law of cosines. So cosine's always going to be in there. What always goes right beside your trig is always an angle measure. What's the angle measure that's across from the side you want to find? This is 89. Okay. Look at your page. This is the most important part. Can you get this set up? Because from here, whether you had a calculator at home or not, or whether you have a calculator that does trig, everybody, a third grader, can punch this in on the calculator. So I know you can do that. This is the most important thing to get. All right, I'm going to punch this in. If you didn't have a calculator at home, please do this, and don't just sit there and be lazy. I want you to do it so you'll get some practice with the calculator. When you punch this in, x squared is on the left side. All of this stuff on the right, you can just put it straight in. You're going to get 413.6699. So I'm going to round it to 0.67. Okay. Now, be careful. This is not your answer. Take a look. 413. If I stopped there, that's unreasonable because I've got 14, 15. For that to be 413.67, that does not make sense in real life. But if you'll look, x is not by itself, and we do need to square root both sides. And when you square root both sides, you should get 20.34 if you round it to 2 decimal places. And does this make sense in real life? 89 degrees is a pretty big angle. We can't get, U and T are going to have to be smaller than that. So take a look. 20.34, it's a reasonable answer compared to these, and also it's bigger than both of these. So we can be pretty sure that, hey, we've got the right answer here. X is equal to 20.34.